Hi, everyone. Thank you for your stay here. It's a real pleasure to be in this event and trying to explain you this topic. It's about next-gen energy AI. We would like to talk to you about asset bundles, Databricks Asset Bundles, and what is the way that we have implemented in our MLOps process. So the agenda, some kind of introduction, architecture of our platform, and a demo, including a demo in order to explain a little bit more about our implementation. Introduction, my name is Alfonso Fernández Barandiarán. I'm the head of the Big Data and Artificial Intelligence in Repsol, platform in Repsol. With me on stage, Carlos Rosado Moral, Machine Learning and MLOps specialist. Some context for every of you, because maybe you don't know about our company, Repsol. Repsol is a global multi-energy company based in Madrid, Spain, and we put our customer at the heart of everything that we do. We are a comprehensive company present throughout the entire value chains in the energy market energy and over 90 countries. For us, we use the technology and innovation using cutting edge in the entire value of our products and so on. We have right now 670 digital initiatives to improve the efficiency and safety and optimize resources. For us, it's very important. Our main asset is the people. So we have a talented team. A diverse team, more than 25,000 people, representing 77 nationalities across 27 countries. We have a very important challenge right now, net zero emissions by 2050. We were the first company in order to set this objective worldwide. And we would like to achieve this with all of these things that we are doing right now. We go more technical stuff. Our architecture in Repsol. We are developed from the 2019, our platform. The name is ARiA. It's our Repsol centralized data and analytics and artificial intelligence platform. With this platform, we are ingesting all of the data in the company. We make all the transformation. We make the MLOps operation and so on. And we offer and we deliver this data to our company. We are using 8 different ARiA design principles. First of all, we have a vision platform. It's not only about that solution. We know that we have to put all of the technology in order to support a real platform in order to deliver data and MLOps processes and so on. The second one is based in a multi-business approach. Instead of different many vertical solutions and so on, we have only one in order to support all of our business. We have a cloud platform. In particular, we are using Microsoft Azure in order to support all of the things. And the next one is about we develop all of our features based in our platform as a service approach. We make all of our features in an incremental way. So every time that we need a new feature for our cases, we add this feature in order to improve the capabilities of our platform and in order to deliver these capabilities to other kind of cases as well. We have a component-oriented architecture instead of a monolithic architecture. I mean MSA, microservice architecture approach. The second one is about that we are using DevSecOps by design. It's extremely important for our company, all related to the security, the personal security, the virtual security, and so on. And we make in the center of our designs all of that. And last but not least, is about a lakehouse vision. We use the best capabilities related to data lake, the best capabilities related to data warehouse, and the combination of that is the lakehouse. Putting on top of that one semantic layer in order to access all of this data. This is the very high-level architecture of our platform. If I go from the left to the right, we have different data sources, streamings, streamings like IoT, like PIOC soft, in order to ingest the data coming in a streaming way from our refineries, for example, and so on. Also, the batch ingestors, we have named whatever database type or whatever system, we have more or less the 90% of that. We are ingesting data coming from SAP, coming from different systems like ServiceNow, Workday, and so on, or other kind of products related to the energy sector and so on. And we are ingesting as well external sources, okay? Like in order to ingest data coming from the weather and combine this data with internal data in order to make a proper models and so on. With all of this data, we have the next layer that is data ingestion. Different component microservices specialized in every kind of different source. Later on, we have data storage and processing. We transfer, first of all, we clean all of this data and we make the transformation that the business needs in order to make the proper ETLs and so on. All of that with different components in order to make a proper data governance, okay? In order to add metadata, in order to catalog all of this data, in order to apply a proper lineage, and so on. Every data that is ingested in our platform is governance. We know every data, we know who has the capability in order to access to this data, and if it's happened, we control what is happening with these people and this data and so on. We have another layer like is cross-component. Suppose related to observability in order to make a proper monitoring of what is happening inside of our platform and so on. On the right, we have the data science MLOps. This sub-platform is where we make the all MLOps support, okay? And we will talk later on about that in more details. And last but not least, the data consumption. We get all of this data, make transformation, and prepare this data in order to a proper consumption for our business and so on. We dive deep, so it is a more technical point of view. You can see a lot of Databricks icons, okay? In the middle, we use Databricks in order to make the cleanup, the transformation, and so on in our batch way. And second one, in the streaming line, on the bottom, you can see again Databricks, okay? In order to make on the fly all of the transformation of the data coming from the streaming. On the right, you can see here with the circle, the MLOps part. And here we are using right now Kubernetes and Databricks. We are introducing these Databricks in order to make a proper support of this thing. Why Databricks in this new MLOps approach? It is a short history about the different steps in our journey in this part. First of all, we were using Kubernetes in order to put and deploy endpoints in Kubernetes, the execution of the models in Kubernetes, and an ML console, a web application, in order to know what is happening inside of this ML lab. Later on, we found out that we need more capabilities, and we chose AML, Azure Machine Learning. So with this approach, we changed the execution of our models, and instead of Kubernetes, we move on to the AML. And in addition, we put new tools for data citizen. Data citizen, with this concept, is people who aren't data scientists, people with no capabilities in order to programming in the, Python, for instance, or whatever, but people inside of the company who want to get capabilities in order to use new technologies like advanced analytics and so on, okay? So it means that we are putting the right tools in order to support this journey. Later on, we found out that need more capabilities in our models in order to put in place GPUs, access, and so on. So it means that we add Databricks to this picture. What's happened with this journey? You know, the movie, when you start to deploy an ML model, 1 hour here means 7 years on Earth. So it was a real nightmare. So the current approach, a combination between Databricks and Kubernetes. Where put the different things? In Databricks, we're putting all the capabilities related to MLOps and LLMOps. All related to GenAI process as well, inside of Databricks. The execution of all kinds of models, again, inside of Databricks. And the new tools for data citizen, we want to put inside of that. And in combination, for Kubernetes, we are creating different APIs in order to make a proper wrappers around the MLOps, for instance, or GenAI as well. And if you remember the ML console, in order to know what is happening inside of that with the models, if it's what is the proper training, the proper deployment, and so on, we are using this ML console, with the new capabilities. And last but not least, all the optimization models in Kubernetes as well. This is the typical picture. There are dozens of different pictures related to the ML process, what is happening inside of ML process. And here we have put different icons in summary, what is happening in the different technologies. On the top, you can see all related to the data analysis, model analysis, and so on. We want to use Databricks, okay? With the Databricks jobs, Databricks notebooks, for instance. On the right, you can see all related to the CI/CD. In this case, we prefer to use Azure DevOps, the capabilities with Git, in order to manage all of these things. If I go to the next one, for instance, you know, in order to put the models and all the control of the orchestration of the training pipeline, and later on related to the deployment, related to the monitoring, and last but not least, all related to the feature store, we want to put the Databricks in order to support all of these capabilities. As you can see, 90% Databricks in our new MLOps model. It is some numbers, okay? I guess that for you is important the money, you know? It's not only technology, it's not only about support the business of your different companies and so on. It's important about FinOps. It is some kind of numbers. On the top, you can see a comparison between Kubeflow and Databricks in order that infra cost, development cost, training and migration models, and so on. But the most important thing in this slide, sorry, because with the text, maybe you cannot see properly, but on the left is the current MLOps before Databricks. So, I mean, using AML and so on. The cost, our calculation was around 280K, okay? If you compare using Databricks for these new models, you can see only two figures. It's about 58K. So the cost is important in this case in order to reduce that. And in order to deep dive, we would like to talk about one important part here, Databricks Asset Bundles. Carlos, all yours.
Hello, I can hear. Yeah? Okay. Hello, good afternoon. In this session, I'm going to explain the base of our project, the Databricks Asset Bundles. Oh, sorry. Okay. First of all, I'd like to explain what Databricks Asset Bundles are. DAV is a YAML files where we can specify all kinds of configuration of our project to be deployed in Databricks environment. We can use Databricks CLI in our pipelines where we can validate, deploy, and run the bundles. We use Databricks bundles to make our MLOps and deploy the models in all environments. But they can be used for any kind of Databricks code deployment with CI/CD. It's a little of introduction about bundles. Okay. Here you can see the overall process for deploying code and model artifacts. Code source control is the primary conduit for deploying machine learning pipelines from development environment to production environment. The pipelines and models are on a deep branch, and changes to the code base are committed back to the source control. It's in the right. Okay. On my request to the staging branch, CI process tests the code in the staging environment. And if the test pass, the new code can be deployed to production via Qt code release. And finally, in production, a model is trained on the full production data and pushed to the MLflow model registry. We're using all of the architecture to using in book of MLOps in Databricks. It's the same, but with a little adaptation. To perform the CI/CD of our models, we can see several types of deployment. The deploy code, in this pattern, the code to train model is developed in a dev environment. And this code is moved to the staging and then in production. Okay. The models will be trained in its environment, in dev environment as a part of the development, in the staging for testing, and finally in the production environment with all of the data. The hybrid model, we have created a hybrid model between the other two patterns as needed to reduce the cost of the retraining in all environments. In the staging environment, only the model is validated with integration test inside the staging environment. It's to reduce the cost about the deploy and retraining in all environments. And finally, the deploy models is another pattern. The model artifact is generated by a train code in the deployment environment. I don't know if you can see well, but for the transcribe. This artifact is then tested in a staging for compliance and performance before finally to production. It's only the training inside the dev environment and upload the model, copy the model in the different environments. It's better to reduce the cost about the retraining or something in the different environments like staging or production. Let's see how you have used bundles in our project. This will be what the use case will develop to orchestrate this task in the model lifecycle. This can be serial or parallel, okay? For example, in this task, you can see no, okay. Here, a pointer. Nice. For example, in this task, you can see that it will be executed in a certain type of cluster. In our case, the name is a small cluster, but we put a different type of cluster like small, medium, large, or per project. Which will involve a series of input parameters to do the training of the model, as for example, the model name, experiment name, training date path, or environment to be deployed. Below, you can see a complete flow in Databricks workflows where we can see all the tasks that are developed to deploy a model, like training, model validation, model deployment, service deployment. This is one example and seeing the demo, but we have a different type of this type of DAGs. In our repository, we have to generate pipelines to perform the action for validate, run, and deploy the task Javier previously mentioned. We can see that Databricks is used with command bundle followed by the action. For example, the validate action is used to validate the format, and I check if the bundle is correct. Okay. The deploy action is used to deploy the code in corresponding Databricks. For example, dev, staging, or production. And then finally, the run action will execute our DAG of tasks. Okay, it's time for a demo. I don't know if you can see well this. Okay, here we have a repository about MLOps. Inside the repository in MLOps, we need 2 YAML files per project, one per integration test, another one for CI/CD process. You can see, for example, in this YAML, this part is for trigger when the pull request is created, launch all of the Azure DevOps CI/CD, because we're using Azure DevOps. You can see all the tasks like install requirements, Vultr, PyTest, etc. For code quality or install requirements previously to deploy the code. And finally, the validate, deploy, and run, for example, the integration test inside Databricks. The other YAML is only for deploy all of the code inside the corresponding Databricks, like dev environment or staging environment. Okay. This is another repository. It's the repository for the use case, for example. This is a sample case given to the data scientist to, for example, generate a sample case with training notebook examples, or, for example, model validation, requirements, etc. We need a resources folder. Inside the resources folder, have for example, the task to orchestrate. In this case, the training resources have the task training. Model validation depends on the training, for example, because it's in parallel. And if you can see the parameters is the corresponding parameters per environment. This is useful for deploying different environments. For example, inside the training.py, we have Databricks notebook source. We use the widgets to deploy for different type of environments. The YAML file sent to this with widgets the corresponding parameters, input parameters like model name, experiment name, train depth path, or something. We're using, obviously, MLflow to deploy the models with, for example, this is an example with metrics, put metrics like R2, RMC. For example, with a demo, if we change the number of leaves and put, I don't know if you see the terminal, sorry. But if you put a comment, git add-in, git commit, and git post. Okay, when the data scientist changes, for example, a number of leaves and generate the commit, go back to the Azure repos. Maybe in our case, it's Azure repos, but maybe works fine with GitHub or something. Generate a pull request to master, for example, feed, days testing. Put the comment and create the pull request. It's only one change in this pull request, but maybe you retraining the model or whatever you want. If you put the pull request, automatically launch the 2 pipelines in Azure DevOps, integration test, and deploy all of the code inside Databricks, the corresponding Databricks. Well, if you go, for example, one of these, you can see all of the tasks mentioned before, like install requirements, code quality, or something. When we go to the task inside the Databricks, for example, we have different types of executions, like in this one, have a different job inside the job, have a different task, like training, for example, training this model validation after, or model deploying, okay. For check if the model is deployed correctly, go to the models and see, for example, days. And it's generating a new version, like version 8 in this case, and tag the production, because we're using a Databricks per environment, not only one Databricks, and obviously always tag a production inside this model. And you can see, for example, the metrics like R2, RMC, or something. Well, in this case, upload the model with a serving endpoint. Well, this is corresponding for this model. You can see this different type of upload models inside production environment, because it's a easy part to upload the model with only pull request and approve, for example, for a data scientist lead or a machine learning engineer lead or something. Well, obviously we found issues and solution, no? We have detected a series of issues where we had to look for some solution, okay? The MLflow recipes. The MLflow recipes is a series of guidelines for data scientists where the code is automated. We detected that we're giving less flexibility for our data scientists. Maybe for our data scientists, it's a good idea because it's very good, but for us, it's not working. Models and endpoints can be deployed by data scientists without control on capacity and names. We need some measures so that these models and endpoints are deploying to the following patterns, for example, okay? Need to implement some measures for visualization, control, alerting, on the cost of deployed cluster and endpoints, obviously. Finally, automated deployments of user groups for user cluster models and endpoints. Okay. Well, about this as a solution for these issues, we have implemented the following some solution. Okay, we working in a different fixes. Okay, but this is the actual solutions. We have implemented an audit system that runs in background every day to detect the models that not meet to the defined criteria. Like, for example, the data scientist upload the model without controlling the name or without controlling the endpoint or something. To reduce the cost in development of models with severe versions, we have implemented a model type of model hierarchy system, which is version is available in the same endpoint. For example, We have a project with a lot of models executed in not parallel, but in the same time in different things, okay? To reduce this cost, it's necessary to generate only one endpoint and call this endpoint with different versions, okay, in the same endpoint. This way it reduces the costs. And finally, for the automated deployment, for the users groups, an automated deployment system has been implemented using Terraform for the group of users or something is work well.
So, very interesting stuff, Carlos. Thank you. And it's not the final of our journey in this matter. And we would like to share with you the next steps, or the steps that we are working on right now. One thing is about the implementation of the feature store, okay? We want to use the Databricks feature store capabilities in order to use this one in this inside of our ML lab platform, okay? In order to add and facilitate to our data scientists the using of this feature store. Right now, we have developed the capabilities related to data and model drift, okay? We want to increase and move these capabilities in this new approach in Databricks as well, in order to add these capabilities in the new platform to our data scientists. If we talk about GenAI, we want to extend and implement more capabilities inside of our, related to the visualization of the GenAI inside of our ML console, in order to facilitate to data scientists, data citizens, and so on, related to these new technologies. Right now, we are at the beginning of the migration. If you remember, right now we are using AML, and a high percentage of our models are running over there, and we need to migrate all of these running of the models in AML to the new approach in Databricks. Responsible AI, it's you know, a very important topic right now, increasing the hot of this topic, and we are adding these capabilities to our platform. And we are developing, using different libraries, frameworks, and so on, these new features inside of the Databricks approach in our new MLOps models. And again, money, cost, it's FinOps. Everything that we are making inside of our platform, we need to understand the proper cost of this. If we make or add some kind of technology, we want to understand the cost of this, the impact in the cost of the platform. And that's all. We hope that it was a very interesting topic, and our experience in this implementation is useful for you. Thank you very much for the attention.